Good morning, dear students. My name is Ferhan Mazher, and today is 11th of May 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O Levels Physics, and today we have set our hearts to solve a paper 4. This is alternative to practical ATP, and we have selected May June 2012 for one paper. So let's start today's paper. The time allowed for this paper is 1 hour. So here we go. So the question coming up on your, and this is the marking scheme. So the paper May, June 2012 for one paper is showing up on your screen. So let's start. A teacher and a group of students investigate the behavior of a copper wire when stretched by heavy loads. A long, thin copper wire is clamped at one end, passes over a pulley. A 1 Newton load is attached to the other end of the wire as shown in the figure 1.1. So here you have a bench. Here, this is that copper wire, which is passing over this pulley. On this end, we have loads, and this is the marker. And here the wire is between in this clamp. And here you have put a meter rule on the bench. Explain why one end of the wire has to be clamped tightly. We hold this wire between these clamps, and we hold it very tightly so that this wire do not slip when we put loads here. Okay, so let me show you my answer. So that there is no chance of the wire getting loose on adding the load. Then the question is, explain why the student watching the experiment must wear the safety glasses. You see, if that wire get loose or if the wire breaks, that wire can be hazardous. It can hurt the eyes of the students. That's why he should be wearing the safety glasses. If on adding the load wire break, it can hit the eyes of the student. So that's why we are wearing those safety glasses. A paper marker is attached to the wire. The length L of the wire from the wooden block to the marker is measured. And the marker and the meter rule are used to measure the extension of the wire as the load is increased. State what is meant by the extension. Extension means the change in the length. The original length minus the stretched length. L minus L naught. L means the stretched length, L naught means the unstretched length. So let me show you my answer. Extension is change in the length when the load is added. Extension is equals to L minus L naught, where L is the stretched length and the L naught is the unstretched length. Okay. Then the question is explain why the marker is attached a long distance from the clamped end of the wire. You see, the marker is here, and from here it is clamped. So this length of the wire is quite large. The larger the length of the wire, the larger will be the extension. It will be a profound extension, I mean, and it will be large extension, enough extension that you can observe it. Longer the length, larger will be the extension. So extension should be enough that it is observable. That's my answer. Okay. Explain why some distance is left behind between the marker and the pulley. You see, we always leave they're talking about this distance. Marker is here. This is the pulley. So we have left some distance here. So when the extension will happen, this marker will move to the right side. So it should not come over the pulley. So we have left some room for this paper marker to move to the right when the extension will take place. So that after extension, the marker has room to move to the right. Okay. Then this is the figure 1.2 shows a magnified view of the wire, marker, and the rule. The left-hand side of the marker is used as the reference point. Use the figure 1.2 to find the position of the marker. So with the help of a set square or with the help of a ruler, you can put a dot, 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 dot line here, and then you can read the position of this. Let me show you. So it's 50.3. So you can see I put dot, dot line here. So it's 50.3 centimeters. Next question is, suggest why a small 1 Newton load is added before the initial reading of the position of the marker is found. So we put a 1 Newton load on the wire before taking the initial reading. And the reason is we want to actually know, the copper wire will have some bands in it. So we want to make that wire tight, and we want that wire to remove those bends. So there might be some kinks. Kinks means those bends in the wire. Load will remove them, and the wire will become tight. Then the question is, explain why it is difficult for a student to read the position of the marker accurately. You can see there is some gap between the marker and the ruler. There is some distance between the marker and the ruler. So that's why it is difficult. There is some distance between the marker and the meter rule. That's why it is difficult to read the exact position of the marker. Then their question is, describe one change to the apparatus to make it easier to read the position of the marker accurately. You can raise the level of the meter rule, so the distance between the meter rule and the marker decreases. Wire can be brought near the meter rule, so the distance between the meter rule and the marker decreases, then more accurately you can measure the position. Okay. Then he says, one of the students takes a series of readings of the extension E of the wire as the load F is increased, as shown in the figure. So when F is 1, the extension is 0. When 6, it's 7. When 11, it's 13. When 16, it is 21. It's 21, it's 26. When 26 is the load, the extension is 33. On the figure 1.4, plot the graph of the extension on the y-axis against F on the x-axis. Start your axis from the origin, draw the line of the best fit. So we have to draw a graph here. It's a 4-mark question. So let me show you. So basically what we will do, on this axis, we will have the load F, 5, 10, 15, 20, 25, 30. On this axis, I will have the extension 0, 5, 10, 15, 20, 25, 30, 35. Then I will plot the points. At 1, it is 0. At 1, it is 0. Put a dot here. This dot is basically here. And at 6, 7, at 11, 13, 16, 21, 21, 26, 26, 33. So I plotted these points, and then I have drawn the line of the best fit. Okay. Then their question is, describe the relationship between F and E that is shown by your graph. The load and the extension, they are directly proportional to each other. The load and the extension, and the load are directly proportional to each other. Okay. Then they say the teacher continues to increase the load. Describe what happens as the load becomes very large. When the load will become very large, the limit of elasticity will be crossed. The limit of proportionality will be crossed. The wire might break. So it becomes easier to extend. The extension load graph will be no more a straight line. Limit of proportionality will be crossed. Wire will become easier to extend. Extension load graph will be no more a straight line. So that was the. So my dear students, that was the question number 1. Its marking scheme is showing up on your screen. You can pause the video and read this marking scheme carefully. Stop, pause this video and read this marking scheme carefully. I have already checked my answers with the marking scheme. Okay, so we are going to the next question. The question number 2. A student uses a ticker timer to measure the G, the acceleration of the free fall. The ticker timer makes a dot on a piece of paper tape every 0.020 second. The tape is pulled through the ticker timer by a falling mass. Okay, so this is the ticker timer. This is the tape. We have put a load here. So this is pulling it down. So after every 0.020 seconds, it's putting a dot on it. Figure 2.2. It says figure 2.2 shows part of the tape after it has fallen through the ticker timer. The dots have been labeled A, B, C, D, E. The student places the tape on the bench to measure the distances between the dots. The student measures the distance L1 between the dot A and B, this distance A and B, and the L2 between the dots D and E, this distance. That's L2. By making measurements, this word is measurements. From the figure 2.2, find the distance L1, L2. So with the scale, I made this one. This was 21 millimeter, and this was 33 millimeters. So convert this into meters and write here. I've done this. Let me show you. So it will be 0.021 meter, and it will be 0.033 meter. Then he says, using the relationship G is equals to 2.5 x power 3 divided by 3 multiply bracket L2 minus L1 bracket close. Calculate the value of the G, giving your answer to two significant figures. We just put the values here, L2 and L1. 2.5 x power 3 bracket start 0.033 minus 0.021 bracket close divided by 3 equals 2, and that you will get the value of the G. So I got the value of the G, that is 9.17, it's 9.2 approximately. Okay. Then their question is, the accepted value for the G is 9.81, our value is 9.2. State whether the value calculated for G in the A second part is too large or too small. Suggest a reason for this difference. Our value is 9.2. The accepted value is 9.8. So our value is smaller than the accepted one. And the reason can be the friction between the tape and the ticker timer, or the reason can be the air resistance experienced by that load which is hanging at the bottom of the tape. So the value calculated is smaller than the accepted value of the G. Reason is friction between the tape and the ticker timer. So that is my answer. So let's have a look at the marking scheme. So the marking scheme of the question number 2 is showing up on your screen. You can pause the video and take your time, read it carefully. It's very important to read the marking scheme. A student compares the conduction of heat through the different metals. A figure 3.1 shows the apparatus used. So here we have a hot water in a metal box. Here we have the rods of different metals. At the end of each rod, we have put some wax, and with the wax, we have attached a P with the end of the metal rod. 4 rods of different metals, each have one end fixed through a cork into a metal box. The metal box contains hot water. Each rod has a P attached to it by wax. Heat from the hot water is conducted to the end of each rod. Describe what happens to the wax and to the P on one of the rods. So when the heat will travel through this rod, conducted through this rod, and it will reach here, the wax will melt and the P will drop to the ground. This is my answer. The wax will start melting, the P attached will fall down. Okay. State 2 factors that should be the same for all the rods in this experiment. All the rods should be same. The diameter of all the rods should be the same. The thickness of the rods, length of the rods should be the same. Okay. The next part, state how the experiment shows which of the metal is the best conductor of the heat. The rod from which the P will drop first, that is the best conductor of heat. So the metal rod from which the P drops first is the best conductor of heat. The student is asked to suggest an improvement to the experiment. He suggests placing several P's along each rod as shown in the figure 3.2. Explain how this gives a better comparison of the conduction of heat through the different metals. You see here you have put several P's. This will give you results quickly. Plus, it will because when there is only one P, the P can drop due to any reason other than that the wax has melted. And here you have put several P's. So that rod will be best from which the most number of the P's will drop first. So it will give you obviously the better result. Metal rod from which the P drops first is the best conductor of heat. This is done. Okay, here. This way, very quickly, the results will be obtained. Results will be more reliable as compared to single P attached on the rod. So let's have a look at the marking scheme. So this was question number 3. Especially the D part, P is closer to heat, falls off more quickly, quicker results. That is what I gave. So you can you can pause the video and you can take your time, read this marking scheme carefully. Reading the marking scheme is very, very important. Compare my answers, your teacher's answers with the marking scheme. A very important habit. Okay. A semicircular glass block is used to measure the critical angle for the light in the glass. So we are talking about this. Okay. Let me reduce the size so you can see. So we are talking about a semicircular glass block. Here we have a ray box from which a light is coming out. Here are 2 points, pins you can say, M1, M2, which will show you the emergent ray. Okay. So they are talking about that diagram on the next page. He says a semicircular glass block is used to measure the critical angle for the light in the glass. Figure 4.1 on the page 111 shows the semicircular block on a sheet of white paper. A student shines a narrow ray of light from a ray box through the semicircular block and draws 2 crosses M1 and M2 on the emergent ray. On the figure 4.1, complete the path of the ray after it emerges from the block. On the figure 4.1, draw the path of the ray through the block. And using the figure 4.1, measure the angle of incidence I where the light passes from the glass to the air. Okay, let me show you. I have done this. So I have done this. So let me reduce the size. So join these 2 points up to this point. Join this line straight to this point. Then draw normal on this point. Then measure this angle. And I have measured this angle. And I can show you how much is this angle with the help of the protector. And that angle was 27 degree. 27 degree. Simple and straightforward. Describe how the student adjusts the apparatus to measure the critical angle for the glass. You may use a diagram to help your explanation. A 2 marks question. So here we go. So move this ray box to the left so the angle of incidence will increase. This emergent ray will come to the right, and after increase the angle of incidence until this emergent ray starts moving on to the boundary between the air and the glass. The angle of reflection here will be 90 degree. This angle of incidence will be called critical angle. So my answer is move the ray box. My answer is move the ray box to the left. Angle of incidence will increase it until the emergent ray travel on the boundary of glass and air. Angle of refraction is 90 degree. Angle of incidence in the glass is equal to the critical angle. So when the angle of refraction here is 90 degree, this angle of incidence will be equal to the critical angle. I hope you understand. Okay. And then we have this one. He says, figure 4.2 shows the incident ray used by another student. The ray in the block strikes the glass air surface at the critical angle. Explain why it is more difficult to measure the critical angle with this arrangement than the arrangement in the B part. So 1 mark question. So let me show you my explanation. Here we have this. Okay. So I draw a tangent here, and you see, then I draw a normal here. So this is the incident ray. So this ray is not entering into the glass along the normal. So when the light is not entering along the normal, the path of the light will change. So when this light will enter into the glass, the refraction of the light will take place, the path of the light, the direction of the light will change. So then it will be very difficult to trace the path of the light inside the glass. When the light will enter the glass, it will refract. So the path of the light will change. To trace its path in the glass will become very difficult. In the B part, you see the light is entering into the semicircular glass block along the normal. So here the light has not changed its path. That's why we are able to trace it. I hope you understand what I'm talking about. So let's go to the marking scheme. So the marking scheme of the question number 4 is showing up on your screen. You can pause this video, take your time, read the marking scheme carefully. It is a very important habit to always compare the answers given even in a video lecture or by a teacher or by a red spot, by anyone. Check them, compare them with the marking scheme. It's a very, very important habit. So we are done. We are done with this paper. So my dear students, today we have completed May-June 2012 physics 4-1 paper. This ATP paper was from the zone 1. I have tried my best to explain you the concepts. If I have made a mistake in the paper, please forgive it. If you find this video interesting, informative, or it has helped you to understand this ATP paper, please share the link of this video onto your Facebook, onto your Twitter accounts, and onto your Instagram. Also share the link of this video with your junior students. If it's possible, subscribe my channel and like this video. So it's a great blessing for me to be helpful, to be able to be helpful to so many students around the world. Thank you very much. Keep praying for me. Have a good day. God bless you all.